In this video, I will show you how to find the absolute extrema of a function. That means the highest value or the lowest value. For the sake of comparison, this point is a relative max, and this point is a relative min. This is a high point on the graph, and this is a low point on the graph. But this is the absolute max because it is the highest point on the graph. This is the absolute min because it is the lowest point on the graph. Notice that this absolute min was previously referred to as a relative min. It's both. But you have to be careful when the endpoints are not included in the interval. This point here at the bottom is still the absolute minimum value of the graph. But this endpoint on the top is not the absolute max because it is an open circle. It's not included in the graph. So in fact, there is no absolute max for this function. You might think since the endpoint is not included, the absolute max will just be the next point down. But unfortunately in math, there's no way to get one point below a particular point. Any point you pick, there's always another point that's closer. So when the highest value is an open circle, there is no absolute max. That would be the same thing if the lowest value were an open circle, there would be no absolute min. So watch out for that. I'm going to show you how to find the absolute extrema using something called a candidate's test. But first you have to find the first derivative as we've done in the past. So h prime, well, the derivative of 5 is 0, so that's gone. And then we have negative 2x. This is h prime. Next, we need to find the critical values of x that cause h prime to either equal 0 or be undefined. There are no values of x that will make h prime undefined, but x equals 0 will cause h prime to equal 0. So this is our only critical value. Now we're going to make something called the candidate's test, which is really just a t-chart where the x values are made up of any critical numbers and the endpoints. So we're going to put these x values in order. So we'll start with the endpoint of negative 3, and then we have the critical number of 0, and then we have another endpoint of 1. We need to indicate somehow which values are included in terms of the endpoints. So notice we have brackets around the negative 3 and the 1. So I'm going to put those brackets right on this candidate's test to remind us that these are included. So the y values are going to come from the original function. So we're going to do h of x equals 5 minus x squared. Now we will simply evaluate the function at each of these three candidates, and whatever is the highest value will be the absolute max, and whatever is the lowest value will be the absolute min. Let's start with h at negative 3. So we'll just write 5 minus negative 3 squared. So this is 5 minus 9, so that'll be negative 4. Now let's do 5 minus 0 squared. This will simply be 5. Now let's do 5 minus 1 squared. This will be 4. So we can see the maximum value is 5. So there's an absolute max of 5 at an x value of 0. There's an absolute minimum of negative 4 at an x value of negative 3. So we're just going to go ahead and write that up the way you would on the AP exam. You would say h of x has an absolute max of 5 at x equals 0. H of x has an absolute min of negative 4 at x equals negative 3. The only thing missing is the justification. You're going to love this. It's important that you label the candidate's test using the words candidate's test because your justification is simply see candidate's test. Before we find the derivative, I would like to rewrite g of x a little bit. Let's write this as x to the 1/3 power. So now I will find g prime using the power rule. The 1/3 goes in the front. I'm going to subtract 1 from the exponent, so I'm subtracting 3/3. So that's going to be negative 2/3 power. Because it's a negative exponent, I'm going to drop this down to the denominator. So I have g prime is equal to, okay, there's my 1/3, but I'm going to put x to the 2/3 power. I need to find the critical numbers. There are no values of x that will cause g prime to equal 0 because the numerator is a constant. If I want to find a value of x that will cause g prime to be undefined, I look at the denominator. I can see that x equals 0 will cause g prime to be undefined. So this is my one and only critical number. My next move will be to set up my candidates test using x values of this one critical number as well as my two endpoints. Make sure you label your candidates test using the words candidates test so we can use this for a justification later. I also recommend that you put a bracket around this first endpoint to show that it is included in the interval, and put another bracket around this endpoint for the same reason. Now we simply evaluate g of x at each of these three candidates. Whatever is the highest value will be the absolute max. Whatever is the lowest value will be the absolute min. So first let's do the cube root of -8. That is -2. How about the cube root of 0? That is 0. And then the cube root of +8 is +2. So we have an absolute maximum of 2 at x equals 8. There is an absolute minimum of -2 at x equals -8. We just need to write that down officially. Here's how you should write your final answer on the AP exam. Because we labeled the candidates test with the words candidates test, we can refer back to that as our justification. See candidates test. Looks like we get to do the quotient rule on this one. Do you remember the quotient rule poem? Low D high, less high D low. Draw the line and down below, the bottom squared will go. Let's run through it again. H prime will equal low D high. Low is t plus 3. D high is the derivative of t, which is just 1. So that's low D high less high is t. And then d low is the derivative of t plus 3, which is just 1. So this is low D high less high D low. Draw the line and down below, the bottom squared will go. So this is the derivative. Can we simplify this at all? I think we have some like terms we can combine. So we have h prime equals, ignore the multiplying by 1, that's not doing anything. We have t minus t, so these t's are going to cancel each other out. So we end up with 3 over t plus 3 squared. Now it's time to find the critical numbers, the values of t that will cause h prime to either equal 0 or to be undefined. H prime will only equal 0 if the numerator is equal to 0. The numerator can't be 0, it's a 3, so forget about that part. H prime will be undefined if the denominator is 0, and we can see that t equals -3 will cause the denominator to equal 0. So this is our only critical number. it's time to make our candidates test using this critical number and the x values from the endpoints of the interval. Wait, I just realized something. When I went to write down my candidates in order, I realized that t equals -3 is not in the interval between -1 and 6. So this will not be a candidate. So the only two candidates will be the endpoints, -1 and 6. That's it. So starting with -1, we would have -1 over -1 plus 3. That's going to be -1 half. So we have -1 half from that. And then now the 6. So we'll have 6 over 6 plus 3, which is 6 over 9, which is 2/3. That means 2/3 is the max and -1 half is the min. Here's how you write your final answer on the AP exam. H of t has an absolute maximum of 2/3 at t equals 6. H of t has an absolute minimum of -1 half at t equals -1. C candidates test. That's your justification. Let's try it with a trig function. So g prime. Do you remember the derivative of secant? It is secant tangent. So we will write secant x tangent x. That's it for the derivative. Let's go ahead and find the critical numbers. Actually, before we do that, it will probably be useful to rewrite this g prime in terms of sine and cosine. So secant is 1 over cosine, and tangent is sine over cosine. In other words, g prime is equal to sine over cosine squared. Now let's find the critical numbers. Where will g prime equal 0 and where will it be undefined? G prime will equal 0 when the numerator is equal to 0. Sine x will equal to 0 here and here because sine is the y value on the unit circle. So in other words, at x equals 0 and pi. So we have two critical numbers so far. Now, g prime will be undefined when the denominator is equal to 0. So where will cosine equal 0? Cosine is the x value, so cosine is going to equal 0 here and here. So that's pi over 2 and 3 pi over 2. So let's write that down. Pi over 2 and 3 pi over 2. But before we go any further, let's check and see which of these values are within the interval between negative pi over 6 and pi over 3. Negative pi over 6 to pi over 3 is actually a pretty small interval. Only one of these critical numbers falls inside the interval, and that is 0. So the rest of these will be ignored. So when we make the candidates test, we will use this one critical number and the endpoints. I'm all set up for the candidates test. Make sure you label it with the words candidates test. I recommend that you put a bracket around the endpoints to show that these two endpoints are actually included. Sometimes they won't be. Now we need to evaluate g of x at each of these x values, and whatever is the highest value will be the absolute max, and the lowest value will be the absolute min. Let's start with secant of negative pi over 6. We know that secant is just the reciprocal of cosine, so let's actually ask ourselves what is the cosine of negative pi over 6. Negative pi over 6 is in the fourth quadrant, because that negative just means we're going to go this way. Obviously, the reference angle is pi over 6. So what is the cosine of pi over 6? That is radical 3 over 2. Hopefully you memorized that a long time ago. But maybe this is negative. It just depends on the quadrant. Is cosine positive or negative in the fourth quadrant? It's positive because it's an x value. So the cosine of negative pi over 6 is radical 3 over 2. That means the secant will be the reciprocal of this, which will be 2 over radical 3. How about the secant of 0? Well, what's the cosine of 0? 0 is right here. The cosine is equal to 1. So the secant will be the reciprocal of 1, which is still 1. What about the secant of pi over 3? Well, what about the cosine of pi over 3? That is 1/2, just something that we've memorized. Therefore, the secant will be the reciprocal of this, which is 2. So now it's just a matter of which of these is the highest and which is the lowest. I think it's clear that 2 is the max, because 2 is obviously bigger than 1, but 2 will be bigger than 2 divided by something. So this is the max. So it's just a matter of which is bigger, 1 or 2 over radical 3. So remember, 2 over radical 4, this would equal 1, right? Because this would just be 2 over 2. So 2 over radical 3 is a little bit less than 2, right? Because it's less than radical 4. So this is sort of like an improper fraction. The numerator is bigger than the denominator. That means that this is bigger than 1, right? Whenever you have an improper fraction, you know it's always going to be bigger than 1. So that means that 1 must be the min, the absolute min. Here's how you would write up your final answer on the AP exam. G of x has an absolute maximum of 2 at x equals pi over 3. G of x has an absolute minimum of 1 at x equals 0. C, Candidates Test.